Day 61. We're going to be drawing on 4 different pages of illustrations in order to help understand all these different things about rocks and their formations. Each one of these illustrations will have its own video. So please try to copy my drawings onto your papers as accurately as you can to make them as similar to what's shown on the video as possible. We want to space things out as I'm showing them so that you end up having room for all the different notes that you're to draw. Okay, so here we have a scene showing the ground level and everything below it, and everything alive is up above. What I want you to do is I want you to draw 5 lines going underneath the flower and rabbit, to be about halfway down until you get to this orange blob. Just about that far. Leave some space here between this oval and your layers. Now, what these lines represent are different layers of sediments that can build up over the years. By sediments, we mean all sorts of different things. We can mean little pebbles. So draw some circles there and label it pebbles. It can also be sand, so have some dots here. Label it sand. Or we might have some plants that are buried, so draw a flower on its side and put organic material. Along with that organic material, you might have, buried fish or other kinds of fossils. So all of these different kinds of materials can be called sediments. And when these materials are compacted together, which means squeezed really hard, if they are compacted and also they have the right chemicals around them that act like glue or cement, these things can be all attached together in a rock, and we call that a sedimentary rock because it's made out of the sediments. So off here, please write the term sedimentary rock. So sedimentary rocks are when pebbles, sand, organic material, fossils, all these things called sediments get compacted and cemented together. So we have to write down made by compaction and cementation. Okay, that's the main stuff that you need to know about sedimentary rocks. Let's go on to another kind. Underneath here, what this represents is a place under the ground where melted rock has come up from deep inside the earth and is collected in one space, and it might have a route going out, but right now we're just looking at this space here of melted rock. Melted rock underneath the surface of the earth is called magma. And when it's under the ground like this, there's lots of insulation above it. And so it takes a long time for it to cool underneath the ground. But when it does cool, it forms a solid rock called an igneous rock. And there are 2 kinds of igneous rock, intrusive and extrusive. Since this magma is cooling very slowly inside the earth, it is called intrusive. So I'm going to write down here cools inside Earth. And I'm going to put that in an arrow. So this magma does this action, cools inside the Earth, and it turns into intrusive igneous rock. So the melted rock on the inside of the Earth is magma. And when that gradually cools on the inside, it will make intrusive igneous rock. Intrusive meaning formed inside the Earth, and igneous meaning that it formed directly from melted rock. Now, since this is deep inside the Earth, it takes a long time for it to cool down. So underneath here, please put cools slowly. And that makes large crystals. Large crystals. Since the liquid turning into solid occurs over a very long period of time, that allows crystals to form in the solid rock as it gradually cools. So to show that, I want you to put really big squares all around your words. This represents the large crystals that can form while it slowly cools. Okay, that is intrusive igneous rock with magma under the ground. Now, when this liquid, hot liquid rock can find its way out, then it's called something else. Then it's called lava. And we're going to write in small letters here, cools after exiting. So after the melted rock exits the ground and pools up on the outside, it becomes lava. We just changed the name from magma to lava when it exits the ground. And I'm going to make this into a big arrow. And once it exits, it becomes extrusive igneous rock. I'll turn it here so you can see the spelling there. Extrusive igneous rock. So when it's liquid, hot liquid on the outside, it's lava. Since it's outside, it's going to cool down with the air blowing over it, or maybe water. And once it cools, it's solid and it becomes something called extrusive igneous rock. Extrusive can be remembered by the fact that the lava has exited the ground, or you could remember that it's because it's on the outside or the external to the earth. Outside the earth, external to the earth, extrusive igneous rock. The lava is exiting to hit the air, all that X stuff to help you remember extrusive igneous rock. The igneous refers to the fact that it was melted and it solidified to become the rock. So we have two kinds of igneous, one on the outside and one on the inside of the earth. On the inside is intrusive, on the outside or external is the extrusive igneous rock. Now, when this lava is cooling, this is out in the air, so it happens much faster than when the magma cools underground. So above here, would you please put fast? And since it solidifies very quickly, it doesn't have a whole lot of time to form crystals. So the crystals are very small. would you please write along the top of this small crystals? And to represent that, put small squares all over on the inside around your words. That is the second kind of rock, the igneous rock. The first kind, once again, was sedimentary rock, made by piles of sediments being compacted and cemented together. The second kind of rock is the igneous, where the melted liquid solidifies into a solid rock. The third kind, then, is a metamorphic rock. By this butterfly here, what I want you to do is to remember some terms from your biology class, and that is that butterflies undergo metamorphosis. Metamorphosis. That is a dramatic change. So when the caterpillar becomes the butterfly, it's obviously a very big change physically for the organism. That's metamorphosis. So we're going to have a type of metamorphosis again with rocks, where one kind of a rock will dramatically change into another kind of a rock directly. It doesn't get melted, it doesn't get moved or anything like that. It just changes in place because of extreme heat and pressure. For instance, down here, where we had the magma chamber, what I want you to do is I want you to draw a big line going around it, like this. And this is the area of the surrounding sedimentary rocks that get heated up by the hot magma as it moves through the ground. So I want you to put hash marks all around it. This is the area where the sedimentary rocks get super hot because of the magma. Now the sedimentary rocks don't melt here, they just get really hot. And that heat can change the composition of the sedimentary rocks to something else. So off to the side here, I want you to write heat changes rocks to a new form. And this new form is going to be called some kind of a metamorphic rock. There are different kinds of metamorphic rocks. It depends upon what you are heating up or what you're squeezing really hard. Please notice that in these three kinds of rocks, metamorphic rock, sedimentary rock, and igneous rock, only one kind is going to contain identifiable organic remains, and that's the sedimentary rock. You might find fish bones or plant or other kinds of organic materials in sedimentary rock, but the heat of the magma, the heat of the changing of the rocks will destroy any of these remains that were visible before. And so you won't have any organic materials that are really visible in igneous rocks or metamorphic rocks. You will only have them in sedimentary rocks. And that's the end of illustration number 1. Please go on to the next video for illustration 2.